So this is the beginning of stiffness method. We will apply this method firstly on a beam. So let's get started. First of all, in this method, uh, let's go one by one. First of all, we find fixed end moment. We assume that all the supports here we have are fixed ended. We'll convert this support here in fixed end in the support. Later, we will apply Doki, which is a degree of kinematic indeterminacy. Here you can see in support A, you cannot shift it in X direction, you cannot shift it in Y direction as well. And you cannot produce any rotation here because it's fixed joint. So no Doki can be applied. It goes for support C as well, but you can apply a rotation in support or on support B, but you cannot uh, make it go in X direction or in Y direction. So here you can see that we can apply only a single Doki, which is for rotation in support B. Later, we find moments for the Doki we apply. Then we superimpose. Then we find actually equilibrium equation. We solve the equation and we find the unknown Doki. If our Doki is 2, then we will get 2 equation. If our Doki is 1, then we will get 1 equation. For this problem, the number of Doki is 1. So we'll get 1 equation. We solve the equation, then we find Doki. আমরা ডোকিটাকে কি করি বের করে নিয়ে আসি we find the Doki. Then we superimpose the moments we get moments for Doki, we get moment for fixed ended supports. Superimpose moments, then we get the moments what we are uh, trying to find out. So let's go one by one. Next page. Zoom it a little bit. Okay, so this is our frame once again. First of all, we'll find the fixed end moments here. For that, we need to know formula, like if it's fixed in that, like this way, and we have say load of say P, and the distance here is A and distance here is B and total length is L. Then the moments here, let's say A and this is B. Moment here in point A is A to the direction of B is P A B squared over L squared, and moment in BA direction is P A squared B over L squared. So applying these formulas, we will get the moments in point A and B, BA direction and AB direction, and apply and for another segment, we will find fixed moments by using another formula, which is say this is fixed end support and we have a distributed load over here. Let's say it's W, and fixed end moment in this joint and in this joint will be the same, and that is W L squared over 12. So applying the formulas, we will get fixed end moments. Say, and for that, you got to make all the supports fixed enders. Here, I will change the ruler supports to fixed supports, and then I will find moments. For that, I will get a moment of like this and this, and this. So if we put the values here, here, and here, we will get a moment of what I have already calculated is 44.08, 58.78, and 168. Sorry, 162 and 162. Then we will apply Doki, and before that, and to say another thing, that is for the moment fixed end moment, we will get reaction also. Like here, we'll get a reaction upward. We'll get here just left of B, and just after B, and a reaction here. So what will be the reaction? So in this point or joint, we will get a reaction of say P B squared over L cubed thrice A plus B. And this point just before B, we will get a reaction of P A squared thrice B plus A over L cubed. And for the UDL, we'll get a value of W L over 2, here W L over 2. Another thing you will have to understand, that is, uh, well, I'll tell that later for Doki. But here you will use the value like 30 multiplied by B. Here B is 8 squared thrice A is, so no, sorry. Here B is 6 and A is 8 and B is 6, and L cubed is L is 14 cubed. So using these values, you will get support reactions. I'm not uh, uh, writing all of them. So here you will get a reaction of 11.8, and here you will get a reaction of 18.2, and here you will get a reaction of 54 and 54. So our first part, which is fixed end moments, is done, and we have found the reactions as well. So the next part is we will have to introduce Doki. For that, we'll go on the next page. Well, now we'll have to do another thing, that is we'll have to apply Doki. For that, we'll do one thing, that is here we can apply one Doki, which is rotation. If we change the support to fixed support and rotate it anti-clockwise like this way, we'll see the support like this way. It is exaggerated this way, and for that we'll get the like elastic shape this way, this way. I think it is pretty understandable. So here we'll get a moment for this rotation what we have applied. Say the u1 is, say the rotation, so the Doki is u1, is u1. So for this rotation we'll get a moment here. So the what will be the direction of moment? Say the moment is this direction and this direction, and here this direction, and here this direction. uh, sorry, one thing is has been mistaken. It will be this direction and it will be this direction. I will explain why the direction is like that a bit later. So before that, let's finish it. We'll get a moment of here 4e modulus of elasticity of the materials multiplied by moment of inertia here, that is I, 4ei over L. Here the L is 14 multiplied by Doki. Let's say the Doki is U1. And for the moment here, 4ei over 14 multiplied by U1, the moment will be half of this moment here. Far end moment will be the half of the moment here. So that will be twice ei U1 multiplied by, sorry, divided by 14. And here the moment will be 4ei. Here the I is twice I over 14, sorry, not 14, is 18 feet. And the moment here will be the half of this moment, which is 4e, sorry, not 4e, twice e. So half will be twice e. I is twice I over L. So these are the moments what we are getting due to the application of Doki. So now we'll get reactions for applying Doki as well. Let's say I'm writing the reaction in, say, in black, in black color, in black color. So here I have already given the direction, but the direction isn't corrected. So I will correct the direction. Well, for the moment here, the moment is applying a like a compressive type of thing. For that, we'll get a reaction upward. Here, the moment is trying to uplift the support. So here, the support will produce a reaction downward. So for that, the support will reaction upward. For that, the support will react make a reaction upward. Well, so how much will be the reaction? The reaction will be 6 ei over L squared. Here the L is 14 for this part. L squared multiplied by Doki. Here it will be 6 ei over L squared E1. Here it will be 6 ei, which is twice I over 18 squared. Here it will be 16e twice I over 18 squared. So these are the reactions and these are the moments. So we have got the reactions and moments both for fixed end moments and the application of Doki. So now we'll superimpose the moments and reactions to, sorry, before that we'll make an equilibrium equation. Here we'll find equilibrium equation at point B because we applied our Doki at point B. So At point B, we can claim that, let's go to the next page. At point B, we can claim that at point B, at point B, we can claim that summation of moment external is equal to summation of moment internal. So at point B, if you can see, there is no external moment. So the external moment is zero, but we have internal moments. We have four internal moments. If you can see, one is 58.78, another one is 162, and other two is these and these 4ei over 14 e1 4ei multiplied by twice I over 18. So we'll sum all of these moments with their negation sign. Here we'll say the anti-clockwise moment is positive and and clockwise moment is negative, and anti-clockwise is positive. So here it is anti-clockwise and it is anti-clockwise as well. So these two twos are positive moments, and here it is negative and this is positive. So three positives and one negatives. So our external moments is zero, and internal moments are minus 58.78 plus 162 plus 6. Is that 6? No, sorry, 4. 4 e I over 14 e1 Doki plus 4 e twice I over 18 multiplied by the Doki e1. So if we solve for e1, which is our variable, we will get e1 equals to minus 141.37 over EI. So if we superimpose or this value in any points, we will get the moments. Let's say we want to find the moment of point A to the direction B. So let's go to the point A. Here, at point A, we have a moment of 44.08 for fixed end moment, and twice EI multiplied by U1 divided by 14 for the application of Doki. So if we superimpose these two values, we will get the moment of point A to the direction of B. So the values are 44.08, it was anti-clockwise, that's a positive, plus it was actually twice e I over 14 multiplied by the Doki. The Doki was minus 141.37 over EI. These EIs will cancel each other, and we will get a value of 23.88. Keep it. 88. Keep it. Let's say we want to find the reaction of point A. How we'll do that? We'll superimpose the reaction for that. So one reaction is this, and the another reaction is this, 11.8. The direction is upward in both cases. So we'll just add the reaction. So that is 11.8 plus 6EI over 14 squared multiplied by minus 141.37 over EI. So these two will cancel each other, and we'll get a reaction of, if I'm not wrong, 7.48 kip. So you can find the moments and reaction for of all the points, just superimposing these moments for Doki and moments for the fixed end moments. So this is how you do the maths. I will uh, do a little bit of revision of it. So first of all, we find the fixed end moments, and we use the loading that is given. Then we apply Doki. Here we apply Doki at point B because we can produce a rotation here at point B, but we cannot produce any short of Doki at point B, A, or at point C. Then we make an equilibrium equation. How many equations we'll make? We'll make equations as many as the number of Doki we have. Then we find out the value of Doki solving the equation. Then we superimpose moments due to external loads and the moments for applying Doki. Here we get these are reactions, and these are our moments for the application of loadings and considering all the joints as fixed joints. Then we apply our Doki here. So I'll explain a little bit here why the direction. See why here the direction is not like that. Why not? Why not that? Because here you can see, just see, if we apply a load here, how it will behave. It will deflect this way, but here due to fixed joints it will remain uh, this way for up to a little distance, because of it can produce a anti-clockwise moments which vanishes these moments, so equalizes these moments. So because of this, the loading creating a clockwise moment and the support creating a anti-clockwise moments. And for that, you can see up to these points, it is actually not deflected. Here is the same case. The loading creating a moment like this way, and this is creating a moment this way. So I think there will remain no confusion regarding the sign of moments. So after assigning the moments and reactions for Doki, we make an equilibrium equation considering that the point where we applied our Doki, the moment exerted due to external, and the moment created due to created internally is balanced. So here we didn't have any external moments, so it's zero, and we had four internal moments. The using this equation, we have only one unknown values. We uh, found that later, we superimpose the moments due to our external loads and the application of Doki. So applying the moments, superimposition thing at any point, you can find moments and reaction as well. So you can find all the moments and all the reactions. Then you can draw HMT and BMD. So this is all for our first problem. We'll do some few problems on beams in next 2 or 3 videos. Thank you.